Hi everyone, welcome back to our channel. Today we are going to practically verify superposition theorem. So before verification, let us try to know the primary equipment what we require. This is a kit, a T network for the measurement of superposition theorem, and here the concept of superposition theorem is, so here we are going to have three circuit diagrams. First we will try to construct this circuit diagram with two sources at port 1 as well as at port 2. Here at input port is excited and output port is short circuited. The next circuit diagram, output port is activated and input port is short circuited. This way of position 1 and position 2 is called superpositioning. That's why the theorem is called superpositioning. Now let us try to do the experiment. So here before to turn on you require an regulated power supply. So this is called regulated power supply. So this is the T network what is provided. So the resistance of the series arm is 1 kilo ohm and 1 kilo ohm, and this is of 500 ohm. So this is the input port where we call it as V1 voltage and current of I1. This output port we have the input voltage of V2 and current I2. Now let us try to give the connections for this. So how to operate the RPS also you need to know. So first give the supply. Okay, so as soon as you give the supply, automatically power will be available to the regulated power supply. So how to start an RPS is, so initially you have to put the current knob in maximum position. There is a way of starting the RPS. So initially put the current in maximum position. This is an regulated power supply where it can supply a maximum current of 1 ampere. So now this is the input port, this is the output port. So now I am trying to do the experiment with source 1 activated. So take the red wire and connect to the positive terminal of the RPS and connect to this wire. So before doing this experiment you can turn off it also. So now I connected the positive to the positive of the input port and from the negative of the RPS to the next input of the port 1. Next one I am connecting the output port. So this is nothing but a output port positive are connected to the positive and to the negative of the RPS I am connecting to the output port. You see here, just I exited the input port and I exited the output port, and you can see here this is 1 kilo ohm resistor, this is a 2 kilo ohm resistor, this is a 500 ohm resistor. So an open circuit is given here to connect the ammeter. Okay, so now I am connecting the terminals of the ammeter. So this is the positive terminal of the ammeter. So current will start flowing like this. Automatically this terminal will act as an positive terminal. So that's why I connected the positive wire here. And negative, the current will enter and current will leave. So this terminal will act as an negative. So the maximum current that can flow in the circuit is only 50 milliamperes. So I am connecting to 50 milliamperes. Then I should take only the upper readings. And here, so two voltmeters are also provided. So just to measure the input voltage as well as the output voltage, but directly it will be indicated in the display itself. So it will make you an more clear. Now I am giving the supply to the RPS. As soon as I turn on the RPS, see that this is a dual channel regulated RPS. So I am measuring the voltage, keep it in channel 1. I am measuring the current, keep it in channel 1. So it can show the voltage and current. So input voltage I have to give an voltage of, so this is the circuit diagram. So RPS is connected and we have to give an voltage of 30 volts. So now I am giving 30 volts. So see here how to give is, already we kept the current in maximum position. Slowly vary the voltage course. You can see what is the voltage is available. Slowly apply the voltage. That voltage also will be shown here. You can see the voltages directly here and the current flows. So slowly the voltage increases and current also will increase. Now the voltage is 28 and then come for fine adjustment, and you can see here now the voltage reaches to approximately the exact 30 volts. So now approximately it is now 30 volts. So now input is 30 volts and output. So now we have to see the output voltage. So move it to channel 2 and move the current also to channel 2, and now already we had kept the current in maximum. So the output voltage is how much? Only 1 volt. We have to apply 30. Slowly adjust the course and it goes to 28 and then go for fine. Slowly increase the voltage. As soon as slowly you increase the voltage, it comes to 30 volts. Now the concept here is, so output port is excited with 30 volts and input port is also excited with 30 volts. The resultant current will be flowing in this ammeter. Okay, so the resultant current will flow in this ammeter. Now you see the current, how much is flowing in the ammeter. We had connected to the range of 50, then you have to see the upper value. So first one is 22 and next one is 24. So after writing the, you have to tabulate a column. So here the tabulated column, input voltage is 30 and output voltage is also 30. Therefore the resultant current is 24 milliamperes. That is the theoretical calculation, and practical also we are getting approximately 24 and theoretically you are getting 25. So only 1 milliampere is the change, nothing to worry. Now let's try to design the second circuit diagram. In second circuit diagram, input port has to be activated and output port has to be deactivated. How to deactivate the 30 volt source means make it an short circuit. How to make the short circuit? Now let us try to see here. So before performing the second connection, first remove the power supply and then two wires are there, remove any one of the terminal and short circuit the end. Okay, now you can see here the output port is short circuited and here we go, we have only input voltage of 30 volts and we are going to measure the resultant current I, and this output port is short circuited. Okay, this is called short circuiting or deactivating an voltage source. Now again give the supply. As soon as you give the supply and I want to see the input voltage at channel 1 move to channel 1, and what is the input voltage we are applying here? 30 volts. So now 30 volts is applied here, so that will flow into this network and the resultant current in the branch will be visualized in the ammeter. So you have to see the upper readings. So upper readings if you go, so 12, 14 and 16. So in the tabular column also you will get the same. When V1 is 30 and V2 is short circuited, the resultant current is 16 milliamps. Theoretically we got 17, practically you will be getting 16 milliamperes. So this is the second circuit diagram. Coming to the third circuit diagram, here it is reverse. We will give the excitation to the input port and output port is short circuited and we will write down the current. So you can see here, this is the current I, this is the current I dash, this is the current I double dash. I is equal to I dash plus I double dash. Why we are writing plus means in this source also current will flow from top to bottom. Here in this source excitation also current will flow from top to bottom. You can see the direction of current, both the currents are flowing from top to bottom, therefore the current will be additive. So the resultant current which is nothing but after doing this experiment you will get 17 plus 8.5 approximately, which will equal to 25. So now we had got, after in our calculation, this as 16 and this as some 24 and we have to get this current approximately to this value. Now let us try to give the second connection. So now what I am going to do is just first remove the supply and now just remove the short circuit and now you change the output port as an input port. So this is the input port, now I am changing. Okay, so now you can see here I am exciting only the output port. So these are the two terminals of the output port. From positive we connected to positive and from negative we connect to negative, and this is the supply I am giving to output port, and this input port has to be short circuited. So input port I am going to short circuit. So indirectly we are deactivating the voltage source at port 1 and give the supply. As soon as you give the supply, so it will show the voltage at the input port is how much? 30 volts, and it is given to output port and input port is deactivated, then you will get the current. So you can see the scale of the current 0, 2, 4, 6 and 8. Okay, so here you are going to get the current of 8. Okay, so now 16 plus 8 is approximately equal to our practical value, which is nothing but 24 milliamperes. This is how to perform superpositioning. So why it is called superpositioning means, so this is position 1 and this is position 2. Position 1 and position 2, how many positions are there? 2 positions are there. More than one position is there. Therefore, this concept is called superpositioning, or more positions are available. So here you can see here the resultant calculation. So I is the sum of I1 plus I2, or I dash plus I double dash. So it's nothing but 16 plus 8, you are going to get 24 milliamperes. So 24 milliamperes is the resultant current when both sources are activated. 16 milliamperes is the current when source 1 is activated, source 2 is deactivated. 8 amperes is the current when source 1 is